the square, we have our function notation, h at x is equal to this quadratic here. So the process of completing the square, you're actually trying to do something. You're trying to make what's called a perfect square trinomial. And you actually encounter these when you're factoring. It has to do with something like this. A squared x plus 2ab plus b squared x. You're making a trinomial that happens to look like this. This general form isn't very helpful, but you'll see in a moment what we're doing and why it is. And the reason we're doing that is because when you factor a perfect square trinomial, you end up with a. Oh, sorry, there's no x there. What am I doing? Sorry, I wrote that a little incorrectly. I was looking at it, I'm like, that doesn't make sense. Let's erase this x. There you go. You end up with ax plus b squared. That's what you end up with when you factor this. You end up with two bases or two brackets that are the exact same. And if you recall, that actually looks similar to vertex form. Vertex form just kind of has an a in front of that. They use different letters. They use like an h, and then there's a k on the outside. But really, the goal here is to make this, because that's the middle part of vertex form. That's what we're trying to do. So in order to do that, we actually, some teachers will focus on all three, but you can really just focus on the first two terms if you like. And what you can do is whatever the a value is, so in this case it's -5, you can common factor out the a value from the very first two terms, okay? And when we do that, that's -5. So -5 comes to the outside, which is great. We already got the a value of the vertex. And then within these brackets, and this +1 is going to stay down here, we simplify. So -5x squared divided by -5 just gives us x squared, okay? 30 divided by -3, that's actually going to give us -6, and then the x comes down, okay? So this is good. What we've done now is we've made a situation where the coefficient in front of x is just a value of 1. So this new b value, there's this little formula we use. It's b divided by 2 squared. We're going to divide it by 2 and then square it. And that's where essentially this piece is coming in, that 2abx kind of thing. We're going to do it because it's going to create a number that's going to allow us to make this perfect square trinomial. So like, the idea is you're reverse engineering it. They don't really describe it the whole way, but you just got to remember, after I've common factored out, I got to apply this little formula. So in this case, we have -6. So -6 divided by 2 squared. Well, -6 divided by 2 gives me -3. And -3 squared gives me 9. So great. What we're going to do next is we're actually going to add and subtract the value of 9 in the brackets. So we get x squared minus 6x plus 9 minus 9. So that's what we were getting. We're getting the value. And the reason we can plus 9 and minus 9 is because when you put them together, plus 9 and minus 9, they equal 0. So all we're doing is adding 0. And when you add 0 to something, we didn't change it. So we actually haven't changed this equation by both adding and subtracting. But what we have done is we've created a scenario where this piece right now, we don't quite know it yet. That's a perfect square trinomial. We've just done that. This little piece we're going to be able to factor. The one thing we need to do is we need to move this -9 to the outside of the bracket so we can get to the factoring part. So we're going to move this -9 out. When we do that, because there's a coefficient in front, we do have to do some multiplication. So when we move -9 out, we'll have to multiply by -5. So that's part of the process. So we'll still have -5 out here. Within the bracket, we've now set up that perfect square trinomial. Okay. The -9 times -5 is actually going to give us positive 45. So positive 45 comes the outside. And we still have that +1. Okay. I know it's kind of running in. I'll put a little wall here so we know where our work and our side work stop. Okay, good. So now that we've done that process, I'm going to simplify the outside to start, just to make it a little easier. We'll start writing this in black here because we're going to focus on another piece. The perfect square trinomial, well, actually, let's start. 45 plus 1, that's going to be 46. Amazing. Great. We've simplified. Now we're focusing on these, on this set of brackets. This is a perfect square trinomial. The fastest way to solve this is to literally just take the square root of the first term and the square root of the last term. So square root of x squared and square root of 9. Okay. What are they going to be? Well, square root of x squared is just x. Square root of 9 is 3. We take the principal root. Technically, it's plus or minus 3, but we're just going to take the value of it. And in our bracket, we take the first term, it's going to be x. The last term is going to be 3. And whatever the operation is in front of the middle term, that's what we bring down. So because it's a -6, we bring down a negative between the two. We factored it so we can put that little squared there. And we technically have vertex form. But I want to show you, because I know that was a shortcut, I want to actually show you the factoring piece. So we're going to do we'll call it the factoring down here. I'm going to take that bracket, x squared minus 6x plus 9. Okay. We can use sum and product because technically this is a value of 1. When you guys did factoring, did you do something like this? We look for two numbers that are equal to a times c, and those same two numbers add to b. We're going to go through this process because we're actually doing that. They've created one that you get a shortcut with. A in this case is 1, and c in this case is 9. So it's two numbers that multiply to 9 times 1, which is just 9. The b value happens to be -6. Well, it turns out, looks like I can use -3, and that fulfills this. Great. So now, when I write out my brackets, I get x minus 3, x minus 3, and because that's the same, we get x subtract 3 squared. So that's actually the factoring. That's how we got to this. But instead of going through this long process here, oh, sorry, you can't see the bottom part. Instead of going through that long process, there is a bit of a shortcut. We can just do this square rooting stuff, and we get the two values, and we just jump from here to down here really quickly. Okay, so what I'm going to do now, I walked you through all the steps. I'm going to do it a little faster with a different question where we would kind of skip. So when a teacher would do this, a lot of times they would skip a step or two. I'm going to do that here on the next page, just so it looks a little more like what you would see. So let's use this one here. I have f at x is equal to -2x squared plus 16x plus 1. Okay, so I'm going to do this usually the faster way. So I'm going to divide the first two terms by the a value here. I'm going to common factor it out. So we get -2. Inside the bracket, we'll have x squared and minus 8x. Are you okay with that? How I got the bracket? Okay. I have a new b value. Remember, we got to apply this little equation. Oops, I drew it too high. There we go. So we have that new b value. So it becomes -8 divided by 2. That's going to be -4 squared. That's going to be 16. So we are going to add and subtract 16 in this bracket now. So we go -2 x squared minus 8x plus 16 and minus 16. And it's the minus value is the one we always bring out, okay? So the next step will be actually take this -16 and take it outside. When we do that, we got to multiply by -2. So our next line looks like this, -2 times x squared minus 8x plus 16. -16 times -2 is positive 32 plus 1. Okay. I'll simplify the outside. So we still have this bracket. We have this perfect square trinomial in the middle, plus 33. And because we made a perfect square trinomial, we take the square root of the first term, which is x, square root of the last term, which ends up being 4. And we just combine it into one bracket. We have x, we have a 4, and we have a negative sign, we put our squared, and this is our completing the square. So